Ladies, gentlemen, gender confused. Today we got a SureFlow diaphragm pump. Website claims it's industrial, however, runs on 12 volt DC, so I guess that's negligible. Decided to no comprende when it was about minus 10 degrees outside, which is the worst possible time this could happen, and shut down the whole operation for some time till we could swap it out. So we're gonna take this apart and see if we can find out what happened. We're gonna start with the pump end. There is some electricals that go in here, so we're gonna take this cap off, see what we can find. This seems to be a flow regulator, which I wasn't even aware of. All right, focus. Fuck. Anyway, this is a flow regulator here. I wasn't aware of that. So that's probably what's inside here, but we're gonna see if we can get at these contacts inside here, because that's where the power goes in. So check that out. We got the screws taken out. Pop this open. And inside here we got a switch. And I don't really know what this is for. Doesn't attach to anything and nothing appears to be broken. And this is the shut off here. So we're gonna test this switch. See if that's the problem. Hook this up here. Alright, well, it appears that the switch in its natural position is open when it's depressed. I'm assuming that means it's closed. We'll check that. And my arm out of the way here. As you can see, when we depress it, it opens the circuit. So that appears to be good. So now we're gonna take the pump assembly off here. See what's inside, just out of curiosity. Come on, you fuck. Oh, forgot a screw. Alright, this appears to be some type of condom on here. Take this off, and here we got the pump head. I don't know how that turns because, like I said, I'm not really sure how this works, but as you can see, these lobes here are catching on the end of the motor. So I'll have to look into that a little more before I go any further and see how this thing works. I should have done that before I took it off, but I figured, what the hell. Might as well let the whole world know I'm an idiot instead of keeping it a secret. So we'll check that out and see what's next. Upon further review of Al Gore's Super Information Highway, I could not find any information on how this diaphragm pump turns rotary motion into linear for the diaphragm action. So I just did what I did before the internet existed, and I figured it out for myself. So what I found out is this contraption here that I was trying to spin does not actually turn. We'll show you how this works, and then I'll take this cover off and we'll find out how it takes the rotary action of the motor and turns it into linear. But I bypassed the switch here, and we'll just hot wire it to my 12 volt power supply here, And I don't know if you can see this action because it happens pretty fast, but what's going on there is it's just vibrating those lobes up and down. As you can, I don't know if you can see that through the camera, but, and then that is what's actually pushing the water. So it's like a butterfly going through the air effect there. So we'll take this cover off and we'll figure out exactly how that works. And in the process of trying to figure out how that worked, I found out that this pump does work. It probably just has a bad switch. So when we put this back together, we're gonna figure out a way to rig that up and just bypass the switch. So, all right, we'll take this cover off and figure out how it makes the rattle. Well, it appears that, focus, there we go. It appears that this bearing, come on, focus, is offset. So it doesn't make a complete round motion. So when it's spinning, it's off balance and it causes it to rattle, and that is what, it stays in place, but it causes it to rattle back and forth, and that rattle action is what is actually moving the water. It's got 3 here, so it can move a larger volume of water. If you just had 1, it would move a very small amount of water very slowly. So it has 3, and the rattle action is what, now this goes over that, and the rattle action here is what produces your water flow. So we'll reassemble this thing and we'll bypass the switch and see if we can get her to work. Just a quick snippet here before I finish the final assembly. We'll show you, now that we got the membrane in place, we'll show you how that works. I don't know if you can see that on the camera, but there's a little vibrator going on there. Now, as I was putting this back together, I remembered that this has a pressure switch built inside here. 45 PSI. I don't know if you can see that. Anyway, these can be used in a multitude of applications. One of them is like a camper or an RV. This kind of pump is what is going to run your sink and your shower and your toilet. So when this is turned on, it'll pressurize the system up to 45 PSI and shut itself off. And then once it senses a pressure drop, it'll kick back on. So since in the application that this was used, this pressure switch is not needed. It is externally controlled, the on and off, by a completely different circuit. So by bypassing this switch and just wiring it up with the wires off the motor, this thing will work just fine. And I don't know if I mentioned this earlier in the video, but this is a $100 pump, and it's for a commercial application for a business. So it's generally just a throwaway because it's not really worth dicking around with. Over $100. However, like I said, it was just going to get thrown away anyway, so I figured why not poke around a little bit and see if we can figure out what's wrong. So we're just not going to hook up the pressure switch, and since we found out earlier that the natural state of this switch is in the closed position, so it'll run no matter what, whether there's power going to this or not. When the power is actuated to this, it opens the circuit and shuts off all the electricity, and that's probably what happened. It just stayed in the open position and did not allow power to go to the motor. So when we just bypass this switch and just hook it up to the power source, it runs. So problem solved. Thanks for watching.